Okay, so today this first part is about a really big, important idea. And I'm actually going to pull from two ideas that we've been working with over the last couple weeks. So first is the power of compounding, and then the concept of E, which we explored last week. And I'm going to put the two together to make a really big, important idea. So let's review this idea of power of compounding. If you remember, there's a formula that I gave you for compound interest in particular, but this could be for any phenomenon, where a to the t, or a of t, the function, is equal to a naught, where this just means the initial value, times 1 plus the rate, the growth rate, divided by the number of times that it is compounded, times, or to the power of the number of times that it was compounded, times t, and that's all in the exponent. So by way of example, let's take $500 at 4.5% interest, okay? If you compound annually, then n is equal to 1, and I'll say this is over 2 years. I'm going to do the exact same problem, and I'm going to set it up, and then you're going to do it with your calculator, and you can pause as you do the calculations and get them in here, okay? But, so the first thing right here is plugging it in. We have 500 times 1 plus 0.045, make sure you change to decimal, divided by 1, because it's annually, so we're compounding only once, to the n is still 1, and its t is 2, because we're doing it over 2 years, and you're going to get a number. So take a minute, pause, and get that number. Then, if I compound monthly, right, what that means is I take the same $500, 1 plus, it's the same rate, but this time I'm going to divide the rate by 12 because I'm doing it once a month. So basically what I'm doing is I'm taking 1/12 of the interest rate, but I'm doing it at the end of every month from a previous lecture. So then there's your 12 to the second power, and that's going to equal some value as well. So pause and get that number, and whatever number you get here should be a little bit bigger than this. Not much bigger, but a little bit more money. So I'll let you pause and get your answer. Okay, then if we go to weekly, right? So we're going to compound more often. We're going to subdivide more. Still borrowing $500 plus 1.045 over 52 weeks. 52 weeks to the second power, because we're still doing 2 years. Run that in your calculator just for kicks and grins. You'll get a number that's a little bit bigger than these, but get them in your notes. And then finally, we're going to compound daily. And this, just so you know, this is how credit cards do it. When you look at a credit card, they compound daily because it's the way they can make the most money. So you're still borrowing $500. You're still at an interest rate of 4.5%. Make sure you use the decimal. This time you're dividing by 365. So every day you're basically taking the interest of this amount by a fraction, a daily fraction of whatever the interest rate is. But then it's to 365 power times, it's still 2 years, and you're going to get another number here. And so what you want to do is crank out that number, and this number right here should be a little bit bigger than all of these. And really, the comparison from here to whatever number you got there should actually be pretty substantial. So crank that out, and then we'll go over to this concept next.